This is problem 947 from the Pearson textbook. So for this one, we're given a stress element. It has 65 megapascals, the stress in the y direction. The shear stress is 20 megapascals. And then we have this line here that's indicating that like we want to see what happens when the stress element is rotated. And so we want to find the principal stresses at 1 and 2, so the maximum principal stresses, tau max in plane, and stress x prime when rotated. So we'll just start like we do the other ones, start with the x face and the y face. So x face is the stress in the x direction, which is 0 here. Y face is that tau, and we're looking at the x face right here. And so this tau is moving in this direction. So that's in a clockwise direction, which is negative, or you can do the right hand rule. So that'd be negative 20. And then y face is going to be 65, so that's that stress in the y direction, and then 20. So it's always going to be the opposite. You can also look, this is the y face, this is the direction it's going in, which is in a counterclockwise direction, which would be positive here. So now we'll draw our Mohr circle. And so we have our 2 points. Let's see, we'll do something like this. Just draw on the axes first. So stress, positive tau. X face is 0, negative 20. So 0, and then negative 20, where negative is up. So go up to here. This is the X face. And then the Y face is 65, 20. So 10, 20, 30, 40, 50, 65 right here. And then 20 right here. Oh, so that's the Y face. I just write 65, comma 20. And the X face was a 0, negative 20. So now we can draw our circle. It's gonna give us a wonky one. Let's try again. Let's draw a circle and then adjust it. Something like that. So now we've got our Mohr circle. Stress 1 and stress 2. We can quickly draw where those are going to be. So stress 1 is going to be over here. Stress 2 will be over here. We need to find that stress average. So let's just draw a line between X face and Y face. That stress average is going to be here in the center. And it's basically 65 over to 0 in the X direction. So that would be half of 65. So that would be 32.5 degrees or megapascals. That's that stress average. We can now find that R. So R is going to be a different color. R, and we know this piece here, that piece of the triangle is going to be, it'll be what, 65 divided by 2. So that's that 32.5. And then this part here is that 20. So R is going to equal the square root of 32.5 squared plus 20 squared. Run it through my calculator. 38.16. So now we know the R. So once we know the R, then we can find the stress 1. So I'll just pink. So we know this distance is 32.5. We know this distance is 32.5, and then we know this whole R value. So from the center out to the principal stress is 38.16. So stress one, or stress one is going to equal that 32.5 plus 38.16. Gives us 70.66. Stress two is going to equal, it's going to be in the negative direction. And we can just do, we know the full R is 38.16, and we can subtract that 32.5 to give us what that value is. Or sorry, move that. It's going to be that 32.5 minus the 38.16. So that's going to give us negative 5.66. That's megapascals. So we have stress one, we have stress two. Oh, did I? Ah, is that a racing thing? So we found stress one, stress two. We need to find tau max. So we'll go back over here. So tau max is going to be the very bottom of it. Tau max in plane. And that's just going to be that R. It's in the positive direction. So tau max in plane equals 38.16 megapascals. And then the last thing they want us to find is that stress prime when it's rotated. So we're going to go to the X face and we want to rotate it. So this is the X face is here, and we want to rotate it in this direction 60 degrees. So we want to rotate it, that's in the counterclockwise direction, 60 degrees. So we go to X face, and then we need to rotate it. Remember, we jump over to Mohr's circle. So we want to rotate it. It's 60 degrees in the real world, then it'll be 120 degrees in Mohr circle world. So it would be down something like that. So it'd be 120 degrees. And that would be that stress X prime. So now we need to figure out, basically figure this out. So we basically need to figure out what this angle is. We know the radius of this. We want to find sort of where it hits right here. We know the whole angle is 120 degrees. We can find this angle alpha, and then maybe find this angle beta. So alpha would be the sine of alpha would be the opposite. So that would be that 20 over the hypotenuse. So sine of alpha equals the opposite, which is at 20 over the hypotenuse, which is r, that 38.16. So alpha is going to equal, let's see, 31.6 degrees. And then so beta, so alpha plus beta is going to equal that 120 degrees. So beta is going to equal 120 minus that 31.6 degrees. So that's going to equal 88.39. I was wondering if I'd drawn it at the right place. Um, but so now we know that beta here is at 88.39. We want to find, so we're interested in, I'm gonna use a different color now. We have, oh yeah, use this one. So we're interested in this distance here. I guess we want to find that delta x prime right here. So that would be the stress x prime. Once we know that distance here in that triangle, then we can figure out what this distance is, and find that delta x prime. But now that we know beta, we know this radius. So cosine of beta is going to equal the adjacent over the hypotenuse. So I'm going to call this, I'll just call it like A or something. So cosine of beta is going to equal adjacent, so that's that A, over the hypotenuse, which is the R, so 38.16. And we know beta is 88.39, so A equals 38.16 cosine of 88.39 degrees. So let's calculate that out. Cosine of 88.39 gives you 1.07. And so that would be 32.5 minus 1.07. And that ends up giving us 31.4. So sorry about that, but that's the, when you actually put the right numbers in your calculator. And that's it. Thanks.